a student sending me stuff yesterday. And
what are you
I
guys
narrowed
giving
it down.
a virus?
I can't pinpoint exactly who, but it's down to about 4 people sent me PDF files of the horrible thing to send when I asked for other things. But 4 people sent me PDF files, and that virus was carried in one of those 4 PDF files. I don't know exactly which one.
Dude,
That's the first time in 30 years of teaching that I've had a student submit anything that's infected. That's the story. Now you notice your test on the front cover said, send back only the file type that you were given. So you got to send me back an ODT. I'm not accepting any PDFs or JPEGs or Mumbo files. It's got to be ODT. And one's with that? Oh, was it intentional? You know, I don't. No, I don't think so. The virus was very smart. It was made by a sophisticated person, and I don't think the people in question could have made the virus. They may have been a carrier. You've perhaps heard of that just like humans carry a germ but show no symptoms, there are some computers that carry a virus and don't show any symptoms. In fact, Linux users in general have been accused of this. Linux users, we don't use antivirus at any time. Never do that in my whole life. But they say Linux users carry viruses and pass them on. We receive them in mail, then we forward that mail to somebody else, and it infects them. And so we're a non-symptomatic carrier. I guess there's some truth to that. So in the final analysis, I don't think yesterday's event was intentional. I think it was just a carrier case. All right. Well, now we're going back to our class meeting for today. We're already deeply involved in time. This subject is rather small. It goes quickly. So it'll fit just well today. I'm going to turn off the video and focus on a shared document. So here goes.
A shared document?
And share. Let's see, which one is it? I'm getting there. It's just trying to find. Okay, you should see. Let's go to the header page. You should be seeing notes that I was creating while you were doing that. This is today's record, and it usually starts out with some announcements. I told you about the video feed and why it's turned off. And what you'll see most of the time, and the fact that I clearly
He's a horrible kid.
Dude, I can't hear. So.
Oh my gosh.
I gotta tell him this is horrible.
Yeah.
I wants to record this. The only issue is by default, Zoom turns all the privileges off. And so if you want to come here and record it, just tell me in the chat room, I want to record, and I open a little button that says allow record.
It's also not me, right? Everyone else?
No, everybody else.
Okay.
So I'll make sure.
To the main topic today is guessing numbers between floats and integers. Okay, the background is on the first week of this semester, I printed out this diagram that's in front of you. Maybe I can't remember. I'll do it now. The T is built up of these components on the left side. And memory is a helpful tool, but it's not in the CPU. So there's a rule of assembly that you can't use registers of two different types in the same instruction.
On the internet.
Okay, it tells me the audio is very poor. Maybe let me try. I have to control my speech and speak very slowly. Speaking into a microphone is like transmitting data. The number of bits just has to get through the cable link. So let me try to remember to speak as slow as right now. Now back up a minute ago. The CPU has four components. You see, I'm pointing at it with my mouse. It has four components, and you know the names of them.
Hear the Zoom, Jose.
The rule is we cannot use a register of one component and another register of another component in the same assembly instruction. And right here on the screen, there's an example of breaking the rule. That's using a register from GP, still very poor quality. It's using a register from two different groups, two different components. It's using an SSE and a GPR in the same instruction, and that won't compile. It won't assemble. Let's go down here. Okay. First, take a look at what this would look like in C++. It's usually called static cast. So here is an integer, number 4, and here's a destination, a double. And that's how you do it. You make a static cast, and it converts 4 into 4.0. I'm getting messages. Okay, so let me try. I am getting messages. Okay, I'm going to try to have this mic even closer to me. And I'll still try to speak slowly. And let's see if this can improve. Otherwise, during spring break, I'm going to go get a new high quality mic and stop using this toy they gave me. All right. So back on the shared document, here's an example in C++ of casting an integer to a double. Okay, pretty simple. And right below it, an example of casting a double to an integer. It looks pretty simple. And here is an example of casting a double to a float. Okay, so why would you say that? Why is that complex? It is complex internally. It does a lot of changing. So I'm going to put a note here. Converts four to 4.0. That looks like it's so simple, but further down, look what actually happens. Look what happens in a simple cast of 4 into 4.0. all 64 bits are rearranged. Well, there's some zeros in the middle there, but the 4 is as an integer is here. Okay, thank you, Tommy. He says he's recording it. We'll make it available. Okay, look at the picture. See how the number integer 4 is stored in a 64-bit integer. And when you convert it to 4.0, a lot of bits are shifted around. That shifting has to take place during a conversion or during a casting. Okay, now let's go. Here's another example. Where's I left out number 2. Here it says in example 3, we're going to convert 8.0 in 64 bits to 8.0 in 32 bits. So let's go. 64 bits, and this is same number, 32 bits. Okay, a casting operation from 64-bit 8.0 to 32-bit 8.0 still results in a lot of changing of the bits. It's not very dramatic, but that's still substantial change in the bits from the source to the destination. So now we're going to do it in assembly. And in assembly, this is the only case I know of where you can mix registers from different components. Remember, the rule is you can't mix 2 registers of different components in the same instruction. But this is, as far as I know, the one exception to that rule of no mixing. All right, well, let's go on. Which one should I do first? Let's do, hold on. What one is first? The C++ example. Okay, it was casting an integer 4 into a double. Okay, so example. Okay. MOV RCX 4. Okay, and 64. Okay, 64. Now, hold on, I lost my place. Just be patient. I lost my place in my handwritten notes. Okay, I think I found it. So it looks like here it is. CVTSI to SD XM M11, comma RCX. Okay, notice that the 2 registers. holds 4.0 in 754. Okay, that's the first example of casting in assembly. It's one instruction. Right here is the key. Put it in bold. Okay, that casts a long integer to a long double and stores it in XMM11. Okay, what about going in the opposite direction? So EXAMP example 2. This will be reverse direction. Okay, so let's put we need a float number. Oh, what should we make it? Well, move. I'm going to create a float number. Move into RDX, 0x4048. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think that's it. Okay, so we have some float number in RDX, and the normal way to transfer that float number is to push it and then to copy it. It will be SD to XMM14, comma, RSP, brackets, and pop RDX. Okay, now we have a float number. I don't know what its value is. It should be easy to figure out. But we have a float number in XMM14. Well, I better use a good terminology. We'll call it a double in XMM14. So the question is, how do we cast it to the nearest integer? And here will be the answer. I lost my place again. Hold on. Okay. CVTS SD 2 SI. And then I think, let me fix the spelling. And we'll go RAX, comma, XMM14. Okay. So what it does, it goes without saying, it takes the float number in XMM14, rounds it to the nearest integer, and stores that integer in RAX. Takes the DOU double in XMM14, rounds it and stores that integer. Okay, so there's conversion from an integer to a float, and from a float to an integer. Those are the two that we'll probably use, more probably. We're going to use those two throughout the remainder of this semester. there's some rare ones that are less useful. Converting a INT to a 32-bit float. I'm not sure I really want to take the time to illustrate those. I'll tell you what, after we end this session, I'll add a couple more examples in 32 bits, but you won't find them very useful. Let me see if there was one other. Oh, yeah, we got to do something else. Okay, suppose you're converting. Here, I'll do this one. Here's example number 3. EXA, example 3. INVOLBI, involving memory. MEM. ORY. Okay, let's say we have an array of integers. So we have an array, WEIG, wait, yes, Q, 30. GHT, weight is array integers. Okay, and so we want to take an integer out, not from a register, but directly out of the array. We want to take an integer out of the array and convert it to a float and store it in SMM. I better state that because I'm not sure you can all hear me, but let me state it. Okay, we want to take an integer out of the array, which is in memory, and convert it to, go with this word process, to 64-bit form. Okay, so here's the example. It's all CVT and SI to SD thing. I'm looking at it. I'm just CVT. I'm looking at it for spelling mistakes. I think we got it. Okay. And we'll put it in XMM12 and 12, and it came from this array in the third slot. WEIGHT plus 3 star 8 brackets. Okay, so there's something more here. It's copying a integer from slot number 3 into XMM12, and in the process, it converts it to a float number, a floating point number. But the issue here is this is one of the cases where keyword is required. It doesn't know how many bits to pick up out of the array. What it has is the starting address, but it doesn't know how many bits to pick up. And so here's a case where keyword is mandatory. This operation will not happen successfully without the keyword here. Keyword is mandatory here. Okay. Keyword specifies, well, let me back up. This specifies the starting address of that integer stored in the array, but QWord says take the next 64 bits, or if you want to say it, take the next 8 bytes from the starting address. I'll put it in the record here. QWord specifies SPECIFIES how many bytes. That's terrible thing here. Bytes to include in the integer. INTEGER starting at a DDRE address WIGHT plus 3 times 8. Okay, it's one case where the machine actually has to be told how many bytes you're going to include in this conversion. If it was a D word, it would use 32 bits and make a 32-bit integer and convert it. See, this one, let's copy the whole thing. Control C, Control D. So I still didn't get it less. You're gonna do that. Means create an integer of 4 bytes. Okay, so there's a difference. Keyword will create a int, as we'd say in C++. It would create an int integer starting at that address, and a QWord would create a long starting at the same address. It just depends what you want to do with it. Let me see if we're covered the grounds for the most part. We've done, I'm looking at my handwritten notes. We've done that part. We've done this one. Have we gone in the reverse direction? Have we gone from, reverse direction was from a flow, from a float to an integer. That's a round off of the float number to create the integer. And I think the one before was the opposite direction, was to take an integer, yes it is, and create a float number out of it. And that's a kind of casting. So I think it's just about at the close. Where is it? Here's the important one. I wanted to put in bold. Here. Okay. And here. Well, I'm coming to an end. I am almost finished. Okay, we'll look at the lecture. If they need it, I'm recording it. So, you ask Tommy for copies. Oh man, I can't do this right. You ask Tommy how to his video. And is this assignment for a continuing lecture? This PHIS is in the category of continuing. We'll see. During the break week, I plan to post. I do believe it includes casting. Let's end. I am staying here to answer your questions. Anybody have a question? Yes. Yes. I will post the document in about 20 minutes. Mm-hmm.